Good morning, children. Nice to see you back again through the video. So, we have completed till this in school the other day. Now we have to start from the next topic, work done by force of gravity. Now you can strike this off. This portion you can cut it off. It is not in the syllabus. So you can strike this off. Now we will start with work done by the force of gravity. Work done by the force of gravity. Okay. So the other day, so we saw about work done. Now suppose you imagine a body of mass m is dropped from a height and it is falling through a height h. Okay, so it is a body of mass m and it's falling through it's been dropped from a height and it is reaching here, which is at a height h above the ground. Now we know that work done is force into displacement. So here force is m into g, okay, because it's under gravity, into displacement is h. So work done will be mgh. Okay, so the work done by the force of gravity is mgh. Now there's another one concept that you need to know. Suppose this height, the person has come down straight. Another case will take, not the person, sorry, the ball has come down straight. Another case, you assume that the ball is rolling down the stairs and it is reaching the ground. In another case, the ball is coming through a lift. Okay, this is stairs, this is staircase, or this is, you can take a ramp. Okay, you know what is a ramp. Okay, so, and this is come straight. Now work done will be the same in all the three cases, though it seems as if it is traveling through stairs, it has to travel a long distance, and here ramp also, it looks as if it has to travel a long distance, but all that we have to see is the vertical height above the ground. So vertical height above the ground. So between the initial position and the final position, the vertical height above the ground is what has to be considered. So this is one thing you can, so work done by the force of gravity is same whether the body comes down from a certain height using stairs or slope or a lift or elevator. Similarly, if a body of mass m goes up through a vertical height h, either directly or through stairs or through lift, then work done will become minus mgh, because g will, for a body going up, g is minus, so it will become, so for a body coming down, it is mgh, and for a body going up, minus mgh. Now, coming to the unit of work done. So, generally units, so how to define a unit, you will go back to the basic formula. So joule is the unit, SI unit of work done. So when do you say work done is 1 joule? When 1 Newton force produces a displacement of 1 meter, then work done is 1 joule. Okay, so 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter. There are some bigger units called kilojoule, megajoule, gigajoule. You know this conversions. 1 kilojoule is 10 power 3 joule, megajoule is 10 power 6, giga is 10 power 9. Then CGS unit of work done is erg. Okay, CGS unit is erg. So 1 erg will be, so the same formula I have to write all CGS units. Force will be 1 dyne. If the force is 1 dyne and the displacement is 1 centimeter, W is F into S. So work done will become 1 erg when force is 1 dyne and displacement produces a displacement of 1 centimeter. Okay, so that is the definition of erg. 1 erg of work is said to be done when a force of 1 dyne displaces a body through a distance of 1 centimeter in its own direction. Next is relationship between Joule and Erg. Okay, relationship between Joule and Erg, the SI and CGS unit of work done. Now start from the SI always. 1 Joule is 1 Newton into 1 meter. We have to convert it all into. So if you remember, last year we had this. 1 Newton is 10 power 5 dyne. 1 meter is 10 power 200 centimeter. So 10 power 7, 5 plus 2, 7. So 10 power 7 dyne centimeter, which is otherwise erg. Dyne centimeter is erg. So the conclusion is 1 joule is 10 power 7 erg. So if they tell you to derive the relationship between joule and erg, you have to do this. Next, come to the topic power. Definition of power. So far all we saw about work done. Okay, so far we saw about work done. Next we talk about the next title is power. Now when we say power, it is with respect to time. Okay, power is work done upon time. Now in this case we are not considering the time at all, how long it took to finish this work. We didn't consider. Okay, in work done we don't see the time, but when we talk about power, the time taken to complete that work also to be included. So formula for power is work done upon time. So this brings the definition. The rate of doing work is called power. Then formula. So this is the formula for power. Formula for power is work done upon time. Then come to units of power. Now factors affecting. Okay, so power depends on 2 factors. What are they? Amount of work done by the source, directly proportional. Time taken, inversely proportional. Okay, so if a machine or anything does the work in less time, it is said to be having more power, because they are inversely related. So if you can finish a work in less time, then you have more power. But if you take more time, power is less. That is the main thing. Okay, we'll be having numericals based on this. We can do that later. Now there is another formula for power. That is, now work done is F into S upon T. Now S by T, distance upon time, is velocity. If you remember, if I group these two together, distance upon time, that will be the velocity. So I get this formula, power is force into velocity. So P is equal to F into V. This is also another formula for power. One is work done upon time. The other formula, if you know the force and the velocity, you can use this formula. Next comes the unit of power. What is the SI unit of power? Okay, what is the, so anyway, to define the SI unit, you take the basic formula. When will be power 1 watt? When work done, watt, the 1 watt, WAT, 1 watt of, when do you say power consumed is 1 watt? When work done is 1 joule, and if it is finished in 1 second, you say 1 watt, the body has a power of 1 watt. Okay, so if 1 joule of work is done in 1 second, the power spent is 1 watt. Then you have bigger units, kilowatt, megawatt, gigawatt. Smaller units are also there, milliunit and milliwatt and microwatt. This is used very rarely, but the bigger ones, yeah, we do use them. Relationship between SI and C. So CGS unit of power will be per second. Very rarely it is used. You can leave that. Horsepower. Now, it is another unit of power mainly used in mechanical engineering. Okay, so usually motor, when they talk about the power of a motor and all, they talk with respect to the special unit called horsepower. So 1 horsepower is 746 watt or 0.746 kilowatt. So you have to remember this, 1 horsepower is 746 watt. Then they have given the difference between work and power. Okay, the next physical quantity that we have to see is energy. Okay, so we saw work done, then we saw power. Now we are seeing the third one, energy. Okay, so what is energy? Energy is the capacity to do work. So energy is the capacity to do work. If you have energy, you can do a work. So definition is very simple. Energy of a body is its capacity to do work. And now, formula for energy will be the same as the formula for work done. It's okay, it's just the capacity to do work. Formula will be the same. Okay, energy's formula will be the same as that of work done, that is force into displacement. Now, energy has some special units. Okay, in the sense, when you know that when you talk about energy, there are different forms of energy. Heat energy, okay, light energy, energy of atomic particles. So like this, there are some specific, there are different um, types of energy, and each one, some of them have some special units. Let's see some of them. Okay, now the general SI unit is joule, CGS unit is erg. 1 joule is 10 power 7 erg. The bigger units of energy are watt hour and kilowatt hour. And I've written here E bill, electricity bill. These units are mainly used while paying the electricity bill. Okay, in the electricity chapter, you will be seeing in detail about it. For now, you just know that bigger units of energy used in calculating electricity bill, watt hour and kilowatt hour. Now, 1 watt hour in terms of joule, 3600 joule. Okay, you remember, you leave off kilojoule. If you remember joule, that is enough. Okay, so 1 watt hour is 3600 joule, and 1 kilowatt hour is 3.6 into 10 power 6 joule. Okay, this conversions you are supposed to know. Then comes calorie. Okay, it's the unit of heat energy. Okay, unit of heat energy is usually measured in a special unit called calorie. Then you should know the relationship between calorie and joule. 1 calorie is 4.18, or you can even say 4.2 joules. It's okay if you write 4.2 joules also. Then comes another unit called electron volt. Electron volt, where this is used, energy transfer in case of atomic particles. Please study the whole thing. Energy transfer in the case of atomic particles is measured in electron volt. And what is the relationship between that and the SI unit? 1 electron volt is 1.6 into 10 power minus 19 joules. So this is the these are some of the special units. So the question that that they ask is, in this, which physical quantity is measured in electron volt? Okay, which physical quantity is measured in electron volt, and what is electron volt's relationship with the SI unit of that term? Basically, you will write energy transferred in case of atomic particles is measured in electron volt, and then they're asking you the relationship between electron volt and joule. The sense, write the relationship between electron volt and the SI unit of that quantity. So the quantity is energy, SI unit is joule. So they're asking you this relationship. Okay, so you should know the name of the unit and the SI unit of that, and the relationship between the SI unit. Okay, children. So with this, theory part is over. Now we have to go to the numericals. Okay. So turn to page 28. We're going to do the numericals given in page 28. Okay. So I'll do few of them and the rest will be homework. Okay. First one. A body when acted upon by a force of 10 kgf, is displaced by 0.5 meter. Calculate the work done by the force, so displaced by 0.5 meter. Calculate the work done by the force when the displacement is in the direction of force at an angle of 60 degree, then normal to the force. Okay, so first case, work done in the direction of force, in the direction of force. So work done will be force into displacement. If it is in the direction of force, F into S. So now force is 10 kgf. We need it in Newton. We need it in Newton. Okay. So into 10. Okay. Now how did it can be 1 kgf is actually it is 9.8 Newton. Okay. But in this sum, in the brackets they have given, they've asked you to take it as 10 Newton per kg. So means you're asked to take it as 10 meter per second square. Okay, 10 Newton actually. So 10 kg will be 10 into 10, that is 100 Newton. Okay, so before substituting here, convert it into Newton. So 100 into 0.5, that will be 500, 10 will go, so 50 joule. Second part, work done at an angle, when the force is applied at an angle 60 degree with the, when the displacement is at an angle 60 degree with the force. So in this case, work done will be Fs cos 60. So F is 100, S is 0.5, cos 60 value is 1 by 2. Yeah, so this will be 50, 5 is 25 joule. Okay, so cos standard values you all know, so we just have to substitute it. Third one, work done normal to the force. Work done by the force when it is displacement is normal to the force. So that means theta is 90 degree and work done is Fs cos 90, that will be 0 since cos 90 is 0. So for the third case, work done is 0. Is it clear, children? So it's very simple. If it's in the direction, use only F into S. If it's at an angle, Fs cos theta, here to use. And main thing is this, don't forget to convert the kgf into Newton. Okay. Now, we'll go to the 8th one. Okay. So, what does it imply? In between all our homework. Okay. In between, okay, I'll just give you a brief idea about all the sums. So, here 6.4 kilojoule energy. Energy, I told you, work done and energy formula will be the same. Okay, so 6.4 kilojoule means a man's, okay, I'll do third also. So a man spends 6.2 kilojoule of energy. So energy is 6.4 kilojoule, which is 6.4 into 1000 joules, that is 6400 joule. Then is displacing a body by 64 meter. S is 64 meter. In time is 2.5 seconds. So you have to find the force applied. So I told you the formula for energy is also the same as the formula for work done. So it will be F into S. Now energy is given as 6400. F we have to find, displacement is 64. So F will be 6400 upon 64, that is 100 Newton. Okay, next is power. Second part you have to find the power spent in horsepower by the man. So you first find the power in watt, then you can convert it. Work done upon time, so that will be energy upon time basically. So 6400 upon 2.5. 64,000 upon 25. If I take 2, 50, 14, 140. 5 times 125, 15, 60. 2560 watt. Power is 2560 watt. But they have asked in horsepower. So what you have to do? You have to divide it by 2560 divided by 746 horsepower. 746 horsepower. This answer comes out to be 3.43 horsepower. Is it clear? So, in horsepower, if they tell you to convert, divided by 746. Okay. Now, in the 7th question, they have given 50 liter of water. So, this is what? Volume. This is the volume of water. You now, first of all, 1 liter is 1000 centimeter cubed. Remember that. 1 liter is 1000 centimeter cubed. For this sum, I'm just giving idea. I'm not going to solve it. So, they've given the volume as 50 liters. That is 50 into 1000 centimeter cubed. Because we need in metric unit. Okay. Not even centimeter cubed. We need it in meter cubed. Okay. So, how will I convert centimeter cube to meter cube? Upon 100 into 100 into 100. Okay, 3 zeros cut, 0 here. So it will be 5 by 100 meter cubed. Okay, so liter first I convert it to centimeter cube, then to meter cube. Or if you want to memorize it like this, or if you want to remember like this, 1 liter is 1 upon 100 and 1 upon 1000. Yeah, I think this is better, right? 1 upon 1000 meter cube. Instead of remembering 1 liter is 1000 centimeter cubed, you remember it is 1 upon 1000 meter cubed. So directly you can convert it. You need not go to centimeter cubed at all. Leave this step. You directly do 50 upon 1000 meter cubed. That is 5 upon 100 meter cubed. Okay. Now, but we don't need the volume. Okay. We have to find the power. So, power is work done upon time. Now, work done is mg okay, upon time. So I need the mass of water, I don't need the volume. So in this sum itself they have given the density of water. Density of water is given as 1000 kg per meter cubed. You remember last year you studied. So volume is 5 by 100 meter cubed. So you remember the formula, density is mass upon volume. So mass is density into volume. That will be 1000 into 5 by 100, 0 will get cut, 50 kg. Okay, instead of giving kg directly, they have given asked you to make this conversion. Then you will find the power. First you find work done, mgh, 50 into g, they told you to take it as 10, and height is vertical height 25 meter. Okay, so height is 25 meter and time is 5 seconds. So 500 into 25, 525 is a 12500 joule. Power is equal to work done upon time. It is 12500 upon time is 5. That is 2500. So 2500 watt. Is it clear, children? So this has some conversion part. Okay. So anyway, I've done the 7th also. Then 8th, a pump is used to lift a 500 kg of water from the depth of 80 meter in 10 seconds. So mass is 500 kg. Mass is 500 kg. So this is the eighth one. Mass is 500 kg and height is 80 meter and time is 10 seconds. Time is 10 seconds. So what you have to do, you have to calculate work done by the pump. So work done is mgh. G they told you to take it as 10. So 500 into 10 into 80. 5 eighths of 40. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 4 lakh joule is the work done. B part, par. Okay, this is the A part. B part, par is equal to 4 lakh upon 10, that is 40,000 watt. Then they have asked something called par rating. Okay, so near par rating you can write input. Basically par rating means they are asking you to find the input par if its efficiency is 40%. Now efficiency means output par upon input par. Any efficiency, generally efficiency when we talk about, this will be the formula, output upon input. Output par upon input par. So efficiency is given as 40%. Okay, and this much is the input par. Now you have to find, this is the output par. You need to get 40,000 watt. So you have to find the, so in place of output par you put 40,000 and you have to find input par. Okay, this is the output par. You have to find the input par. So input power will be 40,000, okay, upon 40 into 100. 1,000. So 1, 2, 3, 4, 5. 1 lakh watt. Okay, that means you give 1 lakh watt as the input, you will get only 40,000 as the output. Where did this 60,000 go? The losses due to friction and other things. That next chapter you have machines. So you just remember this. Par rating means they are asking you to find the input par, and efficiency formula is output par upon input par. So whatever par you found, that is the output, and you have to find the input par. Now 9th and 10th is based on this formula. Power is force into velocity. Okay, force into velocity. I'm not going to do any one of this, you can do it. Okay, here power is in 40 kilowatt, convert it into watt before solving it. Okay, now comes the last few questions. That is all comparisons. Compare work done and then part developed by them. Okay, this is one of the important type of question. It came in 2016. I think this is 2017, this is 2018. Okay, so I'll be doing one sum for you. A boy weighing 40 kg, 14th I'm doing. A boy weighing 40 kgf climbs up a stair of 30 steps, each 20 centimeter high, in 4 minutes, and a girl weighing 30 kgf does the same in 7 minutes. Now as usual, boy and girl. Okay, so a boy weighing 40 kgf, so mass is 40 kg. Okay, we need only mass, so mass is 40 kg. So 30 steps of 20 centimeter each. So what will be the height? 30 into 20, that is 600 centimeter, or 600 upon 100, that is 6 meter. Okay, 6 meter. Then time 4 minutes. The boy does it in 4 minutes. Girl weighing 30 kgf, so her mass is 30 kg, does the same, means she also has to cover the same height in 3 minutes. Compare the work done. So work done is mgh, so 40 into g is 10 and height is 6. Okay, so work done by the boy is 6 4s are 24, 0 0, this much joule. Now work done by the girl, so you can just write work done boy, work done girl. So this is also mgh, and you'll have 30 into g is 10 and height is 6. So 6 3s are 18. So 1800 joule. So they have asked you to compare it. So work done by boy upon work done by the girl. So 2400 upon 1800. So this will be 12 by 9, 4 by 3, that is 4 is to 3. So the ratio of work done is 4 is to 3. And then the ratio of power. So power developed by the boy is 2400 because he finishes it in 4 minutes. Now time is 4 minutes. 4 into 60 seconds, that is 240 seconds. So 240, 10. So power is 10 watt. Power developed by girl is 1800 upon, the girl finishes it in 3 minutes. So 3 into 60, 180 seconds. So 180, again 10. So the power developed is same. So P of boy upon P of girl is equal to 1:1. Okay children, I think this is clear now. So the homework for today will be, you have to complete this exercise. Okay, so whichever I've done, the classwork ones, the rest all will be homework. I think I did quite a bit. This 1 2 3 4 5 I've done, so the remaining 11, so they are all of the same method. You can just keep solving it, and as usual send back the homework to me tomorrow itself. Thank you so much.